Good morning, good afternoon, good evening, I guess depending on where you're joining from today. My name is Chad Schmidtke. I'm the Senior Director for Development of MapleSim, and as the title suggests, I would like to chat a bit today about MapleSim 2022. But that title is a bit misleading because I would actually like to talk about MapleSim over the past few years. I think we can all agree that particularly the last 2.5 has been some remarkable changes for us as a society, and where I don't have the hubris to suggest that the changes in our product have been at the same level as what we've been dealing with as a society. At Maplesoft here, we still think they're pretty remarkable, and I hope that as I go through, you will agree. So to just clarify a little bit, it's probably obvious, I will be talking, as far as Maplesoft products go, I'll be focusing on MapleSim, but I'll also be talking a little bit about Maple, which is the engine MapleSim is built on in the context of MapleSim models. So to start off, for those of you who are familiar with Maplesoft and familiar with our products, I thought it'd be fun to have a little bit of a skill testing question. I've got 4 models here, and the question is, which of these could you have modeled in MapleSim pre-pandemic? Okay, I'm not going to wait too long for you to think about it. Starting in the top left corner, this requires the CAD Toolbox, and the answer is you could have modeled it because actually that edition of the CAD Toolbox came out just at the end of 2019. Although we have made sufficient updates to different CAD versions that are available, this one was possible. Moving to the right, the cable robot that you see there, that one wouldn't have been possible because it needed the ropes and pulleys that released in 2020. The web handling library in the bottom left corner, same thing. You would have needed the 2021 release of the web handling library, or 2021 release of the web handling library to be able to model that. And then finally, this bottom one, it's kind of a trick question. You could have been right either way. You've always been able to model that in MapleSim, but we've made changes or updates to the library that make it much easier to do that. And I'll go into details of that later on. So that's for those of you who are familiar with MapleSim. For those of you who are not, let me just give you a quick overview of sort of the stack of products that work together for the MapleSim, for MapleSim. So there is the sort of the core product, and that sits on top of Maple, and that is MapleSim. That's where you actually construct the model, you drag in components, where you bring in your CAD and you ask basic questions of your simulation and get results. You do basic analysis there. However, MapleSim sits on top of Maple. That's the mathematical engine that it uses. And you can use that engine to do much deeper analysis. Anything available in MapleSim can be pulled out as equations or simulated numerically. You can build apps, which are really just Maple worksheets with embedded sort of GUI or graphical components that allow you to click buttons and show plots to focus in on the part of the model and doing the analysis with over 6,000 mathematical functions in the Maple language. And the last piece there is the connectivity. And that really comes from the understanding that we know that we're part of an ecosystem of tools at your place of work. And so we want to make it possible to do excellent model building, excellent analysis in our tool, but we want to make it possible for you to take that and connect it with other tools in your tool chain as well. So I guess you can kind of get a hint where our focus has been on the last 3 years from the previous slide, but really the goal has been to make it easier to build models, to analyze them, and connect them to the rest of your tool chain. And I should pause here just to say that at Maplesoft, we understand that when customers go to purchase our tools, they're not doing it so they can build a model or just so they can analyze. They're trying to answer questions and find things out and find solutions. And so we recognize that sort of all of these steps are required as part of it, which is why we want to make it easier for each of them. So of course, the first thing you want to do before you want to use it with the rest of your tool chain or before you do analysis is build that model. And often when you do that, if you have CAD or some other previous work, you want to be able to take advantage of it. And that's been a real focus in the last number of years. So The CAD Toolbox, which I mentioned earlier, got a big revamp just before the pandemic, and we've continued to update it since that time. And the big idea behind it is that you can take the CAD that you already have, which probably wasn't designed with simulation in mind. It gives you a pre-processing phase where you can open it up. You can sort of group components together, say, all these move together. I don't need separate pieces in my simulation for them. And then you'll be able to create a bunch of blocks. And the nice thing here is what it does is it gives you your kinetic parameters, so your inertias, it gives you your kinematics, where the joints would attach for this, and allows you then to easily create a model that you connect together in MapleSim and can start asking those questions of. Now, not every model comes from CAD. Sometimes you don't have CAD to start, it's just a concept, and sometimes it doesn't even make sense to have CAD in that framework. Now, we've always felt that MapleSim is a tool that is very flexible. I mean, we're built on a mathematical engine, so it makes sense that you've always been able to take equations directly, enter them in a notation that's familiar to you, and directly generate a component. So that's one way of getting your dynamics in and modeling your system. For those of you who are a bit more into programming or who are familiar with the Modelica language, an open standard for describing DAE systems with discrete events, you can use that kind of a representation to code up a description of a component and bring it into MapleSim and allow you to use it directly in that manner. But for a lot of our customers, the fastest way to building a model is by dragging pieces on. And when they do that, it's easiest if they can have a library that already contains some of the fundamental dynamics that they're looking for. And so there's been a lot of work in the last 2.5 years to extend and add libraries to MapleSim that help our customers do just that. And I should add here that a lot of this has actually come from requests from users. The first is just, I want to look at some of the additions to the core library. There's more than I'm going to list here, but these are some of the highlights in the last 2.5 years. We added the machine elements. And really, again, like I said at the beginning, it doesn't add what you can do. It just makes it easier to do that without having to take as much thought and energy into the inertia matrices and such. As well, frankly, it gives prettier graphics to start, which is always a bonus. We've also extended our hydraulics significantly over the last number of years. We keep adding new components, and that's true for 2022 as well. And in 2022, we also added a new app for the hydraulics library, and that is it allows you to create custom directional control valves. You can define how many spool positions there are, as well as specify what kind of connections each position of that spool valve generates or provides. Similar to hydraulics, we've added the pneumatics library in 2021. This library, again, goes with the idea of the hydraulics library, where we've tried to find that balance between simplicity, so it's easy to construct the model, easy to obtain parameters for, but also the fidelity that you need to be able to model the dynamics that you're looking for. Now, looking to some of the libraries we've added recently, ropes and pulleys was added in 2021 and keeps getting, 2020 and keeps getting additions. This model that you see running here is actually an interesting one. It was from a research project at a university, and MapleSim wasn't part of the research, but after we were looking through the paper and able to model it with the ropes and pulleys library and use it to give the inverse kinematics. So basically defining what length of rope was needed in order to move that box around in the center the way that you see it. You can investigate things here like slippage, cable bending, and wind loading with this library. Tires has also received updates over the past few years. Now, this one might seem interesting because if you've been following us, you think, hey, you guys have been doing a lot towards sort of machine design. Where do tires fit in that? And actually, we've sort of been drawn into this from the autonomous vehicles, both sort of autonomous vehicles driving in cities and such, but also indoor robots that maneuver around. And the reason for this is, and this goes to the comments I made earlier about how we sit on top of Maple and we have that fast portable code that we can generate. Our code is royalty free. It's pure C code that you can just incorporate in a platform. And what we found is a lot of people in the autonomous world, what they want to do is get a vehicle that matches the fidelity they're looking for, and then just hook it into a platform that they're building. And often a commonality is that they're running, thousands, hundreds of thousands of tests. So the code needs to be very portable and very, very fast, which is what, of course, you get when you've got that symbolic engine underneath the hood that we do in Maple. And so this really has grown out, and the additions here have grown out from customer requests. Battery has also received updates. This library has been around much, much longer than sort of the start of the pandemic. But in the latest version, we've added an electromechanical data app to allow you to get a better understanding of the properties of the entropy and the potential for each of the different chemistries in your electrochemical battery. The heat transfer library also is an older library, but also a library that comes from customer requests, specifically for customers that were dealing with moving boundary conditions, or customers who were trying to speed up their early prototyping design. They wanted to find out, they had their FEA, which would do the deep analysis on sort of all of the heating and heat dissipation conditions, but they wanted to find what areas they really needed to do the longer simulations on. And so this gave them a way to do rapid testing on a large sample space before they focused in on their sort of FEA solutions. Added in 2022 is the ability to handle flow changes, sudden and gradual, that come about because of the thermal expansion and contraction in water and air-cooled systems. Okay, so I talked about the web handling. I already mentioned that this is new in 2021. In 2022, we've added the ability to merge, so putting webs together like you see in the bottom here. This is a new library for us. Like I said, just in the last part of 2021, we've had a lot of interest in it, put a lot of development and lots of good feedback that's going to be driving it. You'll see a lot more changes to this in the coming releases of MapleSim. Again, the kinds of things that you can analyze are traction, slippage, disturbance propagation, basically all kinds of things to do with tension controls. Is it better to use a dancer? How do you do it with a load cell? These are the kinds of investigations that you can run with these libraries, with this library, sorry. Okay, so that's a pretty quick overview on some of the changes to libraries, how we've added to them in 2022, but especially over the last few releases. Obviously, once you build that model, the next piece is to be able to get information back from that model quickly and in an efficient manner, and then be able to do sort of basic analysis on it. Now, this part isn't as flashy. Often what it is all the apps and the things that allow you to do sort of quick investigations on your model or allow you to build compound components of a model very quickly. I've listed all of the apps in the latest version here on the right-hand side. Some of the things have been added in the last few years. You've got the kinematic cam app generation you see at the top there. We've made updates to a bunch of those. A lot of work has been done on the optimization and parameter sweep app, but all of these things are connected to making it easier to do that analysis. We also want it faster for you to get that result. In MapleSim, when you hit play, we take that Mandelica description generated by the GUI, create Maple equations, which we then go through all the simplifications and reduction for to generate a fast simulation. And one of the things that we've continued to improve with each release, and 2022 is no different, is to reduce the time it takes from when you hit play to when you actually get that simulation and start seeing the results or the response to the question that you've asked the simulation. For those of you who are following our Mandelica progress, every release is stronger in that regard. And again, we continue to make advances towards our goal of just supporting more and more of those Mandelica libraries that live in the modeling ecosystem out there. All right, you've done your analysis in MapleSim. That's one of the key pieces we like. We like you to be able to bring things in. A real focus, particularly over the past 2.5 years, has been with how we allow you to connect with tools outside of the MapleSim ecosystem. So to start, we've put a lot of energy in the FMI export. And really, you don't need to know the terminology of it, but the important piece is that it's an open standard for describing and encapsulating a model so that other tools can take that model and bring it into a simulation. And a lot of this for us has been a lot of tools in the sort of automation or PLC programming world, where you've got your PLC, you program your control code, and what you want to do is test it before you actually either build the machine or before you shut down a customer's line to investigate a problem. And so you run it against a MapleSim model that can replicate the dynamics that are going on in the actual physical machine and allow you to do testing and iterations on that control algorithm before needing, again, to build that machine or shut down a line. We've been extending our FMI export in the last number of releases, specifically in the solver area, adding variable step solvers, meaning that you can get sort of higher fidelity responses, but also actually creating a new kind of solver, a hybrid variable fixed step, which allows you the determinacy of a fixed step solver, which you need for real time, coupled with the accuracy that you can get from a variable step solver. Now, because our customers have been starting to use this and been giving us more feedback on it, one of the big requests has been, they love the speed, they love that they can grab this and port it to other tools quickly. But what they're looking for is to get all the benefit of the work they put into MapleSim. And what I mean by that is when you build it in MapleSim and you do that analysis, you're getting visualizations. You're getting the ability to go and interrogate any variable in the system. And so to that end, we launched a new product as part of the MapleSim family of tools, MapleSim Insight. And it essentially is a companion to our FMI export, which allows you to, at the click of a button when you export, add what we call insight data to your model. And that means that all the visualization work that you put into your model comes along with that FMU. And then when that FMU gets run in any tool, you get to see, I've shown a picture of it there, but essentially a results manager like the one you would get in MapleSim. So you can do all that same kind of analysis and interrogation on the model. Now, if your tool can't run an FMU, we've also taken steps recently to extend it so that Insight can still talk directly to it. So if you're programming your PLC in something like CodeSys, which can't natively support FMI, you can use a standard industry protocol, Ethernet IP, to connect to Insight, and Insight will run the FMU for you and allow you to still test your control code against that FMU that's running inside of Insight. And because you can see it operating, you still get that visual debugging going on. The other kind of side benefit that's come out of this is that we now have a way for customers, both internally and for their external customers, to work with or interrogate or use a model without being experts or even have a license for MapleSim. Insight allows you to run an FMU that's been generated, change parameters, and actually see the response. It'll run that FMU and give you feedback on how it's being used. Now, I have been in slides here for a little bit. So let me just, because it's a new product, and again, because I've been doing slides for a bit, I'll just show it to you. Here I've got an FMU loaded that was generated from MapleSim 2022. In fact, this is the FMU that comes as an example, a tutorial in MapleSim Insight 2022. So here's the sheet where you can ask for all the probes and pieces. I'm going to flip over to the running phase, ask it to run. And when I do that, it's going to generate and sort of get going here. I can generate or modify parameters on the fly. So when it hits 10 seconds, I'm going to tell it to pause and make the input speed and the output speed the same. It's a cumulator model from our new web handling library. I'll just stop it there. One of the interesting things here is that after I've run, you can see this was a trace of some of the variables I was looking at. I can go back and sort of plot any variable. I do have a plot here that I'm going to pull up. This is sort of the summary tension. One of the new features in 2022 is that we can store results and we can overlay them. So you can start to see how, in this case, the default damping that this model had versus the damping that I was using generates a slightly different response. You can see the tensions are different in the web based on the damping. And this overlay is, again, making this interface closer to what you see in the MapleSim product itself. And it's full 3D, it's fast, it's nimble. And again, it's a way that people can interact with models without even necessarily having to have MapleSim. All right. So let's go back to sort of those three pillars, the model building environment, that deep analysis environment in Maple, and this ability to wrap code and connect it to whatever pieces in your tool chain you have. A lot of our customers will come to us and say, we see how these tools can be used to solve our problem, but we don't necessarily have the expertise internally to do that. A big part here at Maplesoft is actually helping you get to the point where you can use these tools. And the engineering solutions group at Maplesoft plays that role of either providing training to get you there, or in some cases, customers say, I just want to get the model itself so that I can do the analysis on it right away. And in that case, we can build that model for you. So we can either help you construct this, maybe we can build specific libraries that match your dynamics. We can build you apps that allow you to focus in on the part of your model for, repeated simulations that you're going to be running, or even just train you how to do that. We have customers who are building their own apps now that focus in on the kinds of analysis that they are trying to perform. And finally, we can help you take that really fast, really portable code and wrap it into whatever custom solutions you're building, whether they require MapleSim Insight or whether it's just that C code that you're looking for. Okay, I hope that gives you an overview of the kinds of things that are new in 2022 and the kinds of things that we've been focusing on, trying to make it easier for you to build that initial model so that it's faster for you to create and construct the model that you want to ask questions of. We hope you've seen how we've been adding things to apps and the engine so that once you have that model in MapleSim, it's faster for you to get results or answers to your questions and sort of do that basic analysis and the advanced analysis that comes from the pieces with Maple. And also the effort we've put in on allowing you to connect that model from MapleSim, that work you've done, to other tools in your tool chain. And these are three areas that we've put a particular focus on in the last few years and will continue to in the upcoming. So I hope this presentation has been informative and interesting for you. I hope it's been giving you an idea of what we've done in 2022 in the last few years. And I hope it gives you an idea of how you can use these tools or our services to help solve some of the problems that you're facing. Thank you for your time today.